Hello everyone, my name is Jeff Koss. I'm doing a small presentation today for a class that I'm taking at the University of Advancing Technology, and that class is RBT-211. And it's a programming class for microcontrollers using AVR Studio, also known as Microchip Studio. And we are flashing a ATML or ATM Mega 328p with AVR dude and uploading code that way. So we're not we're writing in strictly C or C++ right now. We're not using the Arduino code, which a lot of people do. So we're actually tackling this hands-on. So without further ado, here we go. So when we're programming in C, it's a little different than the Arduino. Um, it's straight to the point. So what we do is we're using Microchip Studio. That's the name of the IDE that we're using, and so I begin by including two different headers: AVR input/output header file and the utility delay file. And I apologize ahead of time. I have a really noisy bird over here, and he is just being obnoxious right now. So anyway, so the AVR IO header file is basically the file that we use to get input output for AVR chips. The utility delay header file is basically a header file that allows us to use a delay function. We're going to be using it in milliseconds. The second thing I do is I define the CPU speed by using f_CPU, and we set it to 16 megahertz, which is actually 16 million. And the L at the end of this means long, so it's a long integer basically. Now we have a main function like we do any program, and inside that main function we basically define a couple of things. The DDRB is what we call, well, let me think here for a minute. I'm drawing a blank. It is a device direction register, and the B at the end of it stands for which register we're actually going to be defining. We're defining register B. This particular chip has three registers, B, C, and D. So what we do is we say or equals 1 into port B5. So what that does is it sets pin B5. We use port to set it as an input or an output. Since we're using a 1, that means that this pin is going to be treated as an output. Now the rest of the pins in the B register we're not using. So that or equals means that we're not going to, pretty much in layman's terms, we're not going to mess with those other pins right now. They're all going to be set to whatever. Right now they're all set to 0 because that's the default 0. They're all going to be set to inputs. The while one is our loop, our main loop basically, that's going to run forever. That's why there's a 1 there. That's actually the first time I used it like that. Usually I just use like while true or something like that, but it seems while 1 is the standard for this. So then we define port B, which means that we are saying that input or output for register B, and we do an or equals again, and we define it as pin B equals 1. So pin B is going to be and this one, it's when you define a port B, instead of a DDRB. It's going to get confusing here, but you'll understand it in a second. Port B is basically how we shut things on and off. Ones and zeros. It's binary, on, off, true, false, yes, no. Okay. So 1 means that it is on, okay, or high. Then we delay for 3,000 milliseconds. I actually had to bump that up a little bit because Even though we're using AVR, you know, and C, I actually have it hooked up to the Adreno, and unfortunately, there's a crystal on it, which is really making it blink faster than what it should. So that's the reason why I'm having it so high. All right, so the second part, port B and equals, and then we have the little tilde sign there. That means we're going to be doing the opposite of what port B was doing. So the opposite of 1 into pin B5 would be 0, or shutting it off or turning it to low. So the and equals means that, well, we're basically using binary or Boolean logic. So if you were to look at it, as my professor described it, as, you know, in an Excel spreadsheet, you would see that there's a comparison there, and that as long as the two are the same, it's going to flip one of them and make it 1 to 0 or 0 to 1. So basically, it's basically just saying, you know what, we're going to do the opposite of what we were doing before. If it was on, we're going to turn it off. If it's off, we're going to turn it on. And then we delay another 3,000 milliseconds, and then the loop keeps recycling itself. And that's pretty much the end of it. So I compiled it. And it ran pretty good. So I had a couple of problems with this. I mean, let me show you this here. Okay, so with this, we have to make our own tools. So I made a tool called a flasher, and basically what it does is, this is the tool that is going to be used to upload this code onto this chip. And I'm using a USB port on my computer that runs into, right now, an Adreno, but I can use an AVR loader. So what we have to do is, we have to basically define command, and basically this is the path right here. The command is basically the path where the executable file for AVR dude exists. AVR dude is basically the upload tool that we're using. Okay, Adreno has one that comes with it, so I'm using that right now until my AVR loader comes in, and I'll be switching to that. Now the arguments here are a little different. So here's the cool thing. So I'm actually going to walk you through this because I understand it. Believe it or not, Professor, I understand this. Let me prove it to you. So let's go into Adreno. Okay, let's go here to Program Files, Arduino, and then we are going to go into Hardware, Tools, AVR, Bin. Now this is where AVR dude exists, the executable file, I should say. Here it is right here. Now I'm going to show you a neat trick. You go up here, we type CMD, it's going to bring up the command window. Now if we type in AVR dude, and we're in the right directory, it's going to give us a list of commands here. Okay, so the first thing you see, let's bring this up, is -C. And then you see a bunch of stuff after that. That -C means that is the configuration file. That's going to be the location of the configuration file. And that is actually located in D, Program Files. Yes, a lot of good stuff until the end of configuration file. Okay. So the -p, it stands for the part. We're using an ATmega 328P. The C, the little C here, stands for the programmer. What kind of programmer are we using? So I'm actually using the Adreno board. Now the P is going to be, the big P is going to be, where's the big P at? That's the little P. Where's it at? There it is, port, the port number. So mine just so happens to be on COM3. And then B is, little b is the baud rate. So we define it as 115200. And then U, big U, stands for, you type file name or format, and basically we're going to be, in layman's terms, basically this is All this is saying is that we're going to be uploading this to this chip using this. Okay, I don't know the exact terminology for it, but this is what flashes the chip. Okay, so now that we know that, I named it Flasher. We're okay. So yeah, so it finally flashed good. But let me show you what happened here. So if this isn't done right, it'll mess up. I had a quotation mark before C. Okay, and what it was saying is that the file was invalid. It took me like 3 hours to figure out that I had to take that quote out. Now, the reason why we have quotes in these programs is because Microsoft likes to put in white spaces, and this program just so happens to not like that. So we use those quotes to kind of get around it. Anyway, there it is. Now the next part, you're going to see the light flashing. Thank you very much, guys. And hey, Professor, if you like what you see, give me an A, please. All right. Okay, here's a little video sample of me programming in AVR. Basically, I programmed this thing to flash using the Microchip Studio and flashing it using AVR Dude instead of the Arduino. We used the Studio to write the code, and then we used AVR Dude to flash it and upload it to the Arduino, which is a lot more professional than using Arduino, I guess. Anyway, here it is. Thank you very much.